In this video, I'm going to give a partial proof that the determinant of A transpose is equal to the determinant of A. I'll do it with an or plus minus sign. Now, suppose A is n by n. That really should have been stated up here. A is n by n. The determinant of A, by definition, is the summation of plus or minus A1, J1, A2, J2, all the way down to AN, JN, and this is over all permutations of J1 through Jn, which are the numbers 1 through n. Okay. Now, this summation is equal to the summation of plus minus. Now, if I switch the I into J, that is, if instead of A1, J1, I write A, J1, 1, transpose, they're equal. Then I have A, J2, 2 transpose all the way down. Well, if I transpose that, I get A, J, N, N. But then when I transpose it back, I get what's above it. Okay. Now, J1, okay. J1, J2, J3, that's an ordering of 1 through n. Now, one of these is J1. Okay, so basically, I want the first one here. I want 1 here, and 2 here, and 3 here. So I'm going to have the summation of plus minus A transpose 1. I'll talk about the second component in a moment. A transpose 2. Talk about the column value. All the way up to A transpose n. Now, if this happened to be 1 and this happened to be 2, so there's my 1 and there's my 2, if that was 1 and that was 2, well then I would have J2 here and Jn here. What's happening is that I'm going to have a permutation for the column values, K1, K sub 2, all the way up to K sub n. Now, there's a little error here, because although pretty much this equal sign is valid, with one minor exception. The plus minus comes from, let's go to the top one. It comes from the number of inversions that I have for J1 through Jn. Now, it turns out that, I forget the exact statement, but it won't matter. It turns out that when I reorder these, so I have 1 first for the row and 2 second for the row, and then eventually n for the last row. It turns out that the number of inversions on Kn and the number of the inversions on the J sub n's, either they're exactly the same, I forget, either they're exactly the same or they differ by an even number. Okay, and either way, if they're exactly the same, then we're going to have the same sign. And if they plus minus, that is, I'm not off by a sign, and if they're not the same number inversions, they differ by an even number. Now, if you have an odd number of inversions, well, that means we're going to use the minus. Now, if you add or subtract some even number, it's still going to be odd, which will mean negative. Keep the negative sign. Now, if you have an even number, which means even number of inversions for the ji's, and you add or subtract an even number, you're still going to get an even number, which is positive. Negative stays negative, positive stays negative. Sorry, positive stays positive. That is, these signs don't change. Now, one last statement. This last line, I really don't need plus minus anymore. Of course, all of these is under the permutation of the ji's. And here is a summation of all the ki's. But by definition, this here is equal to the determinant of A transpose. So once again, let me get rid of that question mark, that check mark. When I come from here to here, yes, no question about it, the summation of this is equal to the summation of that. But now, the plus or minus sign comes from, so the equal sign so far is valid. Now, the number of inversions determine whether we keep the plus or the minus sign. Down here, the number of inversions will be the same as the number of inversions up here. The number of inversions down here is equal to the number of the inversions up there, plus or minus an even number. And remember, an even number is 0, so just in case they're the same, I can get away with saying that they differ by an even number. That is, the parity won't change. If you're negative and you add an even number of inversions, it'll stay negative. If it's positive and you add an even or subtract an even number of inversions, it'll still stay positive. The parity doesn't change. And that's what I didn't prove. That's why this is a partial proof. So up to a plus minus sign, I did show that the determinant of A is equal to plus or minus the determinant of T. But I am telling you, it's plus. They both have the exact same value. That completes this video. As always, if you like videos like this, subscribe to my channel. If you want to see other videos like this that I haven't made up already, please leave in the comment section or video that you would like me to produce. As always, watch and learn. See you in the next video.